Welcome students. Today we will solve third numerical on kinematics of particles. So let us start today's lecture. So we are given one statement over here. Let us read that statement. A driver is driving his car at 60 km per hour. When he observes that a traffic light 250 meter ahead turns red. The traffic light is timed to remain red for 20 seconds before it turns green. The driver wishes to pass the traffic lights without stopping to wait for it turns green. Calculate the required uniform acceleration of the car. In the B part, we have to find the speed of the car as it passes the traffic light. Okay, so let us solve the first part. That means we have to find the required uniform acceleration of the car which driver should maintain in order to pass the traffic lights without stopping to wait for it turns green. So it is mentioned in the problem that the car is at a distance of 250 meters when driver observes the traffic light, and traffic light is timed for 20 seconds for that distance. So we have to find what acceleration driver should maintain so that he should pass the traffic lights without stopping. Okay, so for this, let us first see what is the initial velocity of the car. So initial velocity of the car is given to us as 60 km per hour. And we are given other distances in terms of meter. Over here, you can see 250 meters are given. So let us first convert the velocity of the car into meter per second. So let us convert this into meter per second. So for that, we have to multiply it by 1000 because we have to convert kilometers into meters. Then we have to divide it by 3600 because we have to convert hours into second. So we will get velocity as 16.66 meter per second. So this is initial velocity of the car. And in the A part, we are given these two values, that is the distance between the car and the traffic lights and the timing of the traffic lights. So over here we have given time of 20 seconds, means if driver don't want to stop at the traffic lights, then he has to drive his car in such a way that he should travel this distance of 250 meters in 20 seconds. By the time he reaches to this position, then he will get green light and he will not stop and he will continue with the same pace. It means we have to apply this logic over here that the driver should drive in such a way that he should travel this distance in 20 seconds. So we are given distance equal to 250 meters and we are given time equal to 20 seconds. And we are also given its initial velocity, that is 16.66 meter per second. And we have to find what acceleration he should maintain so that he should exactly travel this distance in 20 seconds. Now we have to find uniform acceleration. It means this is a case of uniformly accelerated motion. It means those three equations are applicable to this problem. Now we are given distance, we are given time, and we know initial velocity also. So what we have to find? We have to find acceleration. So in these three equations, we have acceleration in all the three equations. But in this equation, we have final velocity also. But for this situation, we don't know the final velocity of the car because acceleration is not known to us, that we have to find. So this equation is not useful for us. Similarly, over here in this equation, we have final velocity. So it means this equation is also not useful for us. So depending upon the data we have to use this equation only. S over here represents the distance, that is 250 meters. Initial velocity we know, that is 16.66 meter per second. And time we are given as 20 seconds. And it means we are left with only one unknown that we can find through this equation. So it means for a part we will use that equation, that is S is equal to ut plus half at square. So let us put the values of x as 250 meter, t as 20 seconds, and u as 16.66 meter per second, and we'll get value of acceleration as minus 0.416 meter per second square. So minus means this is a retardation. Driver has to retard his car in order to travel this distance in 20 seconds. So we have got the first answer, that is answer for the A part. Now we have to find B part. Let us see what we have to calculate in B part. We have to calculate the speed of the car as it passes the traffic light. Okay, it means we have to find the final velocity. So what is the situation now in the B part? In the B part, we have initial velocity of the car, that is 16.66 meter per second. We have the distance traveled by the car, and we need to find final velocity, that is after the traffic lights. So stage 1 is when observer observes the traffic lights. Stage 2 is when car crosses the traffic lights. So initial velocity is given to us, final we have to find, distance we know, time we know. And we have already calculated retardation also. So for B part, we have retardation, we have distance traveled between stage 1 and stage 2, we know initial velocity, and we have to find final velocity. It means, let us see which equation is applicable over here. So we know retardation, we know the distance, we know initial velocity, so we can use this equation. Over here also, we know initial velocity, we know acceleration, and we have the time. It means we can use this equation also. So these two equations are applicable for the second part, that is B part. So let us use the first equation, that is v equal to u plus at. So put the value of u, initial velocity. A is retardation over here, that is minus 0.416. Put the value of A, and time is 20 seconds. So we will get the value of final velocity, that is 8.34 meter per second. So I hope this numerical is clear to you. Thank you very much.